Okay, still we have many things to discuss in loads, so we can continue that. What kinds of loads and how to input those loads. So we will go back to the loads. Okay, I will continue with the same file, and then general, and then loads and definition. Okay, so date load and then live load we have. So what else we can go for? I'm just going for a load case details add, and here we have so many loads. Okay, so if you want any, you can just go for. Okay, otherwise we will go to the live load itself, and then I'm just going to add some loads. So this loads we will discuss. Self weight, you know. Nodal load, you know. Okay, even you can able to give displacement. Okay, so particular some particular value 0.05 meter, something like that. And if you want to provide even moment, you can just provide. Okay, this is for nodal load. Okay, how it will look like? For example, if I'm just going for displacement, it is in 2 meter, but it is in my, it will be in degree. This is for meter and this is in degree. Okay, I will just go for Fy. I will just go for minus 0.01 meter, something like that, and add. You have made a change to the structure. As a result of this, post processing result will no longer be available. Do you want to delete all the result files? Yes. Okay, then again you can go for analysis and we can just go for post processing. Okay, this what I will do in the sense like I will select these 2 nodes and then assign to selected nodes. Can you able to see the displacement symbol, nodal displacement symbol? And if you want to change that to a moment also, we can change edit, and you can just go for my, but you need to provide the value minus 5 degree, like that. Some value you need to provide that it will be in degree. Okay, but mostly displacement it will be in mm. Okay. And then we also have member load. In member load, uniform force. The concentrated force we seen. Okay, now we will see uniform force. Uniform force is something, it will be evenly spread all over the distance. Okay, now I will put the minus 2.5 kilonewton per meter in global y. See, it is in y direction. Add. Select that, it is in question mark. You need to go to this member and select this and assign to selected beam. Can you able to see the uniform distributed load?
Yes, I can see. I have one question.
Yeah.
What is the difference between local y and global y?
This is what we are discussing in the beginning. Local axis, global axis. So local axis vary according to the member. Whenever you are tilting the member, the local axis also vary, but global axis not going to change. This XYZ, it always remains the same.
Yes,
okay.
Yes, I remember.
Yeah, but shift I, when you're putting shift I, the member orientation, it will keep on changing based on the member. For plates and everything, it will be applicable. Now it is like only the beam and beam and column. Here we can't able to say. Okay, shift I. Okay. Okay, now we can also go for uniform moment. See, here you can also specify based on the preview, the values here. So uniform load over a particular distance, not overall span. Then you can provide the value accordingly, D1, D2, like that. Okay. So for example, we will just go and edit this. See, I want only in the first half. Okay. So the total span, how much? If you want span, where you can just go for. See, here you have dimension, display node to node distance. These things you can make use of. Okay.
Okay, one question.
Yeah.
It is asking D1 and D2. How we can know that from which end D1 is starting, which is the start and which is
okay,
the end of the game?
Okay, that we can just see trial and error method. Mostly it will start from here. It will start from left and it will go to right. That we can just see in trial and error method. So display node to node distance, we will see. So this is 5 meter, right? Okay, now we will just go for edit. So 0, na? So here, see, that's what here also they mentioned, from left until right in X. Okay. So D1, I will put D1. So some 2. Okay, and then D2 I will put 4. So in between 4 minus 2, the 2 or we can put 5. Or no, I think we can put 3 in that case. Or we can put 1 and then here 4. And we can change it. Can you able to see? Here 1 and then we have 4 and then 1. So 1 and 1 both side, and then in between we have concentrated load. No, we have uniform load. Now you understood, na?
And D3 will be 0.
No, D3 will be
If it is
0. Why?
in
Because D3 in the sense it is acting in the middle of the member. See here I section. If you want to put that somewhere, na, then you can put the value.
Okay.
Yeah. Now concentrated force we have seen, and then concentrated moment. If you want moment, you can put some value for the moment. So it is also at the middle, it will act. Select the beam and then select, assign to selected beam. The moment, the value here we can't able to see why. Then you can just go for symbols and label, scales, and moment. Point moment very less. Now you can go for apply immediately. See, now you can able to see the value. Oh, it is like this. Then we need to change. It is not practical. Okay, I will just go to edit, and then I will change to Z, or I will change to some other axis if you want. Got it? Now it's okay. So based on your requirement, we can able to change the moments also. Now we also have linear varying. See, this is uniform varying load. I was telling both well in the beginning. Do you remember?
Yes.
Yeah. If you want triangular load, you can apply this. Otherwise, if you want like uniform varying load, you can apply this. For example, I will put a minus in the sense going downward. Now that's why 1.5 minus 2.5. Okay, and I will add, and this I will put here somewhere, and then assign to selected beam. Can you able to see how it is acting?
Yeah.
Okay, and I will add another also, member load, linear varying. I will select only this, then we will get this kind of things. I think minus 2.5 is not needed. Now we can go for positive. Okay, and then it is local Y. Okay, we will see the result, and then later we can change. Select, assign to selected beam. Okay, then we need to provide minus. I need that side. Okay, since it is local, this is what the difference, local Y. It is acting in local Y, but in globally it is in X only. That is what the difference. Okay, trapezoidal load in the sense like you can able to have distance also, but here we can't able to have distance. But here we can able to have distance. That is what the difference. Okay, for example, we can just go for -1, -2. So distance we will put 0, and D2 we will put to 1. 0 and then 1. Okay, then add, and then I will select this, assign to selected beam. Can you able to see where it is coming automatically?
Yeah.
Okay. If you want another that side, you can just add member load, trapezoidal, and you need to put what is the value? Like we need to put -2, -1. So D1 we will put 4, and then D2 we will put 5. Okay. Can you see? Very simple. Like you need to utilize your logical brain, so we can able to do everything here. Okay. Okay. In member load, what are all the things we have? Okay, hydrostatic. So hydrostatic we will see later when we are doing water tanks. Okay, and then this is for pre and post stress. See here only you need to apply the force that you are going to have and eccentricity. See pre-stress, post-stress cables you have. Do you aware of that? Pre-stressed cable,
Yes,
post-stressed cable.
Yes, slabs.
Yeah. Okay. Yeah. Flat slabs. For flat slabs they use this kind of pre-stress. Okay. In that case you can make use of it. Okay. Now I'm not going to deal with that. So fixed end. So if you have any like value for the fixed nodes, start and end nodes, you can put the values. Okay. These are all the peculiar ones. Like if you want, and if you have such a criteria, then you can apply, and then you can just input the value and you can able to apply to the member. Okay. This is like as it is. Only you need to apply the value and you need to add and you need to assign. Okay.